Dear students, today we will try to understand the thermal properties of solids. We understand that if we have a solid and if we heat up it, then after some time the heat will transfer throughout the material, and the amount of energy which is required to raise the temperature of the solid to 1 Kelvin or 1 centigrade is defined as specific heat, which is further either at constant volume or at constant pressure, which is named as Cp or Cv. Now, how the heat transfer inside the solid? We understand that solid are made up of molecules, which further are made up of atoms. So it means a solid is composed of atoms separated by some distance, and if they are arranged, we name them as crystalline solids. Now, when we heat up this corner of the solid, the heat transfer from one atom to next atom to next, and then throughout the material, the atoms, they don't remain in the mean position, but they vibrate at mean and extreme position, which is named as atomic vibration. When the heat is transferred throughout the material, then after some time all atoms, they vibrate at their mean and extreme position, which is named as lattice vibration. So now we understood that what is lattice vibration and specific heat. Now if we experimentally if we plot this C with the temperature, that is, say this is temperature and this is C, then the graph is like this. That is, at low temperature there is sharp increase in C, and at high temperature C becomes independent of temperature. It means, for example, say this is say 100, this is say 10 centigrade or 10 Kelvin, and this is say 11. So to increase the temperature from 10 to 11, we need this much of energy, and to increase the say this is 90 and this is 91. To increase the temperature from 90 to 91, C remains same. That is, specific heat at high temperature become independent of T, and at low temperature the specific heat varies sharply. To understand this further, this is actual data which was observed from the experimental data. To understand this further, the three different theories were given. The first theory is classical theory. And other second and third, they are quantum theories. Now when the atoms vibrate, they may vibrate independently, or there may be dependence. So according to classical, and secondly, when the energy transfer from one atom to next atom, that can be either continuous or quantized. Means either the energy can have any value or some quantized value. So classical theory says that first postulate of classical theory is that atoms vibrate independently, and second, the energy which transfer inside the solid from one atom to another atom is continuous. So further, if we derive further the average energy and then we calculate the C, that is the rate of change of energy with temperature, we find that C is equal to, according to classical theory, 3 NkB, which says that C is not depending upon temperature. But experimentally we see that C has strong dependence on temperature. So it means classical theory fails to explain the experimental data, and hence we say finally that the atoms cannot vibrate independently. This is false, and also the energy which transfer inside the solid cannot be continuous. So this theory is named as classical theory of specific heat, which fails to explain this exact graph of thermal properties of solid.